Okay, welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here. In this video, we're looking at the language, notation, and conventions of angles. So by the end of this lesson, you'll be able to explain key terminology associated with angles and find the size of missing angles in angle problems. The majority of this video will involve me just speaking a lot of heavy content, so it will be quite content heavy. And then we'll go through a few questions. So let's have a look at the first part of this lesson, key angle terminology. So on the left here, we've got the diagrams. In the middle, we've got what it's called. And on the right, we've got the definition. Okay, so here we can see these are called points. And a point is shown using a dot and is labeled with an uppercase letter. So here we've got points A, B, and C. Often we like to use the letter P for point as well, just so that you know. The second example, these are called line intervals or line segments. So here we've got a line interval CA and CB, or the other way around, AC and BC, doesn't really matter. And an angle is formed by joining two line intervals together. In angles, they are usually referred to as arms. So we could call this an arm here, and we will call that an arm as well. The vertex is the point where the two line intervals meet. So here, that is the vertex. Okay, another way of thinking about it is the corner. Okay, corner, not the edge. We can think of the edges as the line intervals or the arms, and the corner is the vertex. The plural for vertex is vertices. That's the plural. So if we have a square, there are 4 vertices. 4 corners, 4 vertices. Okay. Here we've got the angle. Okay, so when two line intervals meet, the angle is formed at the vertex. And we always write angles with the angle symbol. So this is the angle symbol. And 3 uppercase letters, okay? The middle letter is always the vertex. So in this case here, we've got angle ACB, where the middle letter is the vertex, the corner. We could write the other way around, angle BCA, as long as the middle letter is the vertex. So if we wanted to think about it, ACB goes from A to C to B, and that's the angle that's formed. Or the other way around, from B to C to A, forms that angle, same thing. So this is the symbol for angle, and the middle letter has to be the vertex, and there has to be 3 letters. We do not use angle C. We don't use just 1 letter. We always refer to the angle using 3 uppercase letters. The reason for this is because sometimes we might have an angle like this. Let's say that's C. A, B, and D. What is angle C? We don't know. Is it all of that? Is it just that bit? Or is it just this bit? Okay, so we always use 3 letters. So if we want this bit here, we can say that's angle ACB. If we want just this bit here, maybe I'll use purple. That's angle BCD. And we want the big one, all of it, we refer to that as angle ACD, from A to C to D. And that gives us the whole thing. Okay, so use the angle symbol to refer to an angle, and always have 3 uppercase letters where the middle letter is the vertex. Okay, adjacent. The word adjacent means next to. So adjacent angles are two angles that are next to each other. They share a vertex and an arm. So here we can see that they share the vertex and they share a common arm. They share that one. So I'll say angle ACB and angle BCD are adjacent. So whereas angle ACB, and where's angle BCD, BCD, they are right next to each other, they are adjacent. They share a common vertex C and they share a common arm CB. Okay, complementary. Complementary angles are two adjacent angles that add to 90 degrees. It has to be two only. It can't be three, it can't be four, it can't be more than that. Okay, there have to be two only that are right next to each other that add to 90 degrees. So here in the diagram we say that A is the complement of B because they add to 90 degrees. Here we've got a right angle. That's 90 degrees. So if we were to have A is equal to 40 degrees, the complement to that is 50 degrees because 40 plus 50 is 90. Supplementary is very similar, except instead of it adding to 90 degrees, the two adjacent angles add to 180 degrees. So here we've got a straight line. A straight line has 180 degrees. So here we can say that G is the supplement of H. So whatever G is, if we were to add H, we'll add to 180 degrees. So if G was 80 degrees, H would have to be 100, because 80 plus 100 is 180. Now the best way to memorize this, because sometimes I know a lot of students get confused between complementary and supplementary, which one adds to 90, which one adds to 180. I like to just use alphabetical order. C comes before S, and 90 degrees comes before 180 degrees. So these two belong together. Complementary is 90 degrees, supplementary is 180. Okay, vertically opposite angles. Now vertically opposite angles are formed when two straight lines intersect each other. And the vertically opposite angles are equal. So here we've got two straight lines that have intersected each other. And the two vertically opposite angles, this one is vertically opposite to that, and they are actually equal to each other. So if the dot was 35 degrees, the other dot's 35 degrees as well. And this X is vertically opposite to that, and they are equal to each other. So if the left one is 100 degrees, the right one's 100 degrees. Okay. The important thing to know is that that purple cross and that orange dot, that will actually add to 180 degrees because they form a straight line. They are supplementary angles. They are two angles that are adjacent to each other, and they form a straight line. So whatever the purple one is plus the orange one, it will add to 180 degrees. Okay. Let's have a look at the markings so you understand what the markings mean. The markings in this diagram indicate that AB is equal to AD. That AB is equal to AD because they both have one line going through them. We can see that BC is equal to CD because they both have two lines going through it. So we know that they are both equal in length. And we can also see that angle ABC, ABC is right there, is equal to angle ADC, which is right there. And we know they are equal because of the markings. They both have that one little curved line to show that they are equal to each other. If they don't show any curved markings, we don't know that they are equal in size. Or for the size, if there's no markings, we can't assume that they are equal in length. Alright. We should notice from primary school, acute angles are greater than 0 but less than 90. Right angles are exactly 90 degrees, and we use this little square here to indicate that it's a right angle that's 90 degrees. An obtuse angle is greater than 90 but less than 180 degrees. Straight angle is 180 degrees. Reflex angle is greater than 180 but less than 360. And a revolution is exactly 360 degrees. Alright, so let's move on to the second part of this lesson, which is finding the size of missing angles. Now, for each of these questions, I don't want us to just write down the value of each of these missing values. I also want us to write down the reason why A is equal to a certain number, or B is equal to a certain number. Okay, so from here we can see we've got a right angle, so we know that this is equal to 90 degrees. And we've got complementary angles here. We've got A and 30 are right next to each other. They share a common vertex and a common arc. And because they're complementary, they add to 90 degrees. So A has to equal to 60 degrees. Why? I'm going to put the reason in brackets. Complementary angles. Complementary angles, we like to use this symbol. Add to 90 degrees. What is B equal to? Well, we know that angles at a point add to 360 degrees. Okay. Well, we already have 90 degrees, so what's missing? B has to equal to 360 minus the 90 degrees. And that's 270 degrees. The reason being, angles at a point add 360 degrees. Okay, question B. For question B, I think finding B is actually easier. B is equal to 65 degrees because they are vertically opposite angles. And we know vertically opposite angles are equal to each other because this one is vertically opposite to that. Vertically opposite angles are equal. What about A? Well, we can see here that 65 and A are supplementary angles because they are two angles that are right next to each other and they form a straight line. So that means they must add to 180 degrees. So A has to be 180 minus 65, which is 115 degrees. I'm going to write here angle sum of a straight line. You could say, if you wanted to, supplementary angles add to 180 degrees. Both of them will be accepted. Okay, two more questions. Question C. we can see we've got supplementary angles here. Whatever 2a is and whatever 3a is, they will add to 180 degrees. So 2a plus 3a, that's going to add to 180 degrees. Why? I'll give you the second reason. Supplementary angles add to 180 degrees. Or again, you could say angle sum of a straight line. What we're now going to do is we're going to simplify the left-hand side. 2a plus 3a is 5a is going to equal to 180 degrees. And so if we want to work out a, we need to divide both sides by 5. And what do we get when we divide 180 by 5? We get 36 degrees. And that's it. So that means that this angle here, the left one, the 2a, has to be 2 times 36. This has to be 72 degrees. And this one here has to be 3 times 36. 3 times 36, which is 108 degrees. And when we add them together, 72 plus 108, we get 180 degrees. So we can double check our answer to make sure we got it correct. And yep, that makes sense. Okay. Last one, question D. We can see here that there are 3 angles that form a straight line. So that means when we add them together, we will write, it will add to 180 degrees, but we cannot use this reason here. They are not supplementary angles because supplementary angles only refer to 2 angles, 2 adjacent angles. Here there are 3. So we have to use this explanation here, angle sum of a straight line. So I'm going to write A plus a right angle, that's 90 degrees, plus 2a minus 12, that's going to equal to 180 degrees. Reason being, angle sum of a straight line. Now that I've done that, I'm going to tidy this up by collecting like terms. We have a plus 2a, which is 3a. We have 90 minus 12, which is 78. And that's going to equal to 180 degrees. I'm now going to minus 78 from both sides. (3a) is equal to 102. And now I can divide both sides by 3, which is going to equal to 34 degrees. We can double check our answer to make sure we did it correctly. If we reckon a is 34, we'll replace that with 34. 2 times 34 is 68. And 68 minus 12 is 56. So we'll replace that with 56. So let's add them all together. 34 plus 90 plus 56. Does that equal to 180 degrees? 34 plus 90 plus 56. Yep, it equals to 180 degrees. So we know we did that correctly. Okay, so now you should be familiar with the language and notation that we use for the terminology in angles. And you should be able to use your understanding of angles to work out any missing angles. Thanks.